Hello, sir. Sir, can you hear me?
Uh, Rahul, you can start. Rahul, you can start.
Sir, I don't have the rights for the presentation. Can you make me the presenter?
Okay, wait. Now I think you can.
Yes, sir, I can share.
Actually, I was in one meeting, so that's it.
Oh, no problem, sir. Shall I start, sir?
Yeah, you can go ahead.
Okay. Good afternoon, everyone. Today, me, teaching assistant of Deepak sir, is going to discuss the orthographic projection. Today's class will be divided into two sections. First, we will have the fundamental of orthographic projection through a PowerPoint presentation. That will be followed up by uh, a demonstration of orthographic projection of a simple isometric view in the AutoCAD software. So I think you all can see my screen and I'm audible also. So let's start with the discussion. The very fundamental thing is to understand what do we mean by orthographic projection. I believe you all are familiar with the projection. Projection is nothing but a little synonymous to shadow of an object on a particular screen when the lights are falling onto it. What is orthographic projection? We are going to discover now. The content of the presentation will be the fundamental of the projection, or I can say the principle of projection. What is the objective of the projection? Why do we project something? Followed up by the orthographic projection, the topic for the discussion today. Then various fundamental things to be discovered before we go for the orthographic projection of a given solid object, which includes principal planes, about which you might be familiar with vertical plane, horizontal plane, and all those things. The quadrant, the axis, to the production unit for the fabrication of these components, or these three dimensions need to be read to understand that what basically that three-dimensional object is there. So projection is a way or a tool through which you convert a three-dimensional object into a two-dimensional sheet, and from that two-dimensional sheet you can imagine or you can read out and interpret that what three-dimensional object projection it is. That's what is the objective of a projection. So basically you are converting a isometric view, a three-dimensional view, to a two-dimensional drawing on a sheet of paper for better communication. Then if we are doing this, if we are converting a three-dimensional object to a two-dimensional drawing on a paper sheet, then there are certain questions we need to answer. That what about the dimension size? Are we going to keep the same size? Are we going to increase the scale? Are we going to decrease the scale? What we are going to do? Now, when in the reality, when you are going to project the image of a given object, then the height of the image, you might have studied in the physics, optics physics, the height of the image is basically depends on between the distance between the light source and the object. So let's see here. Let's say you have an object AB and there is a light source. Now from this light source, the lights are falling on this object ends, and you are going to get a image of that object on a screen. Now in this case, you are going to see a very enlarged object A, B. Now let's say if I move the image slightly back, sorry, if I move the source a little back. Now, what do you think? What will happen to the size of the image? Will it increase or will it decrease, or it will the size remain same? Can anybody guess?
Decrease.
It will decrease.
It will decrease, definitely correct. So when you increase the distance between the light source, the size of the image will decrease. Now this is the fundamental of the physics. Now when we are going for orthographic projection, we do not want to increase or decrease the size of the image. We want to communicate with the accurate dimensions. For that, now can you tell me that how can I get exactly the same length of the image what object we have?
Parallel light
Parallel line.
source.
Parallel lines. Very good. So that's what we are going to do in an orthographic projection. See here. In an orthographic projection, what we are going to do is we are going to use parallel lines falling on a given object whose image whose projection we are going to trace on a screen. Now, did it hit your mind why the projection is called as orthographic projections? Because the light rays which are falling on the object or on the screen are perpendicular, and that's why we call it as orthographic projection. So I believe I have justified the topic, orthographic projection. What do we mean by orthographic projection? Let's go ahead. So you can see now, even if I have now, what do I see here? I see here that though AB is slightly slant in position, but the projection is going to get a straight projection. Now in this case, what is the relationship between the image and the object, between their lengths? Is it the
Length of
same?
image will be less.
Image is smaller than the object.
Okay, then such kind of image is called as, I believe you might have studied in engineering graphics in lines. There is something called true length, and then there is something called as, can you recall? Something called as apparent length. not the actual image or actual size of the object, but it's an apparent size of the object. So that's what it is saying, that the size of the projection may be either true or apparent to that of the actual size, depends upon the position of the object, how the object is being positioned in given frame of reference. Let's go. Now we will discuss about principal planes of orthographic projections. Now, there are fundamentally three types of planes we have: vertical plane, horizontal plane, and a profile plane. Now, sometimes a single plane of projection would be sufficient to describe the object, like we saw in the previous slide. In this slide, can you tell on which plane I have drawn the image or the projection?
Vertical.
Very good. Yes, it's a vertical plane. Do you need a horizontal plane for this? No, we do not need a horizontal plane. Knowing that it's a line, it's a two-dimensional object itself. So if we are drawing the projection of a two-dimensional object, we do not need much planes to describe other dimensions, because other dimensions are not so significant. But when you are going to use a three-dimensional object, then the fundamental requirement will be at least two views, or I can say at least two planes you are going to use in order to clarify the observer that what objects projection you have drawn in these planes. Sometimes three would be necessary, sometimes two will also be suffice. Okay, so let's talk a little more about this plane. Let's see. You have a three-dimensional object, a very familiar object. You might, maybe many of you might be having in your home, in the kitchen, a matchbox. Okay, now I am going to, now I'm trying to make a orthographic projection of this matchbox. Okay, let's see. This is what we have as a vertical plane behind the object. Okay, I am looking from this side where the arrow indicates, then what shape I'm going to get on a vertical plane? Can you?
Rectangular. Rectangle.
Uh,
Rectangle.
yes, it will be a rectangle. Exactly. See here, I'm using parallel lines which are orthogonal to the projection plane. That's why it is orthographic projection. And I'm going to draw a rectangle. So this is the front view of this matchbox. So this is how the matchbox will looking from the front. So I have drawn its projection on the vertical plane. Okay. Now, is this enough?
No, sir.
No.
No, sir.
Why?
No, one
Why?
thing.
Yeah.
Because
Why it's not enough
We
is
have
because
not
there
find the
is.
depth. We have not find the depth. We have only find length and breadth.
Yes, Marinal. We have not actually quantified the depth of this matchbox. It could be quite a thicker box. It could be quite a slim box, which contains only 5 sticks or 10 sticks, or it can contain the 100 sticks also. So one view is not good enough for us to understand that what actually this matchbox is. So what I'm going to do is I'm going to see the matchbox from the top. Now, if I'm going to see the matchbox from the top, what I'm going to see?
a rectangular shape.
Once again, I'm going to see a rectangular shape, but this time the rectangle will be different from the front view, what I have drawn on the vertical plane. Now, this time the rectangle will be a smaller rectangle, which I am drawing using these projection lines. These red color lines are the projection lines, which are orthogonal to the plane. So this is what I'm going to see. This is I'm going to see. Now, if I need further more information, then I'm going to look to this matchbox either from the left side or from the right side. In this case, let me look from the right side of the matchbox. So if I'm going to look from the right side of the matchbox, once again, I'm going to see a rectangle, which I can trace like this. And this will be the complete, sorry, this will be the complete picture of that marked matchbox on a two-dimensional sheet of paper over this different planes. Now still, can you tell me that though I have drawn two-dimensional pictures here, on the vertical plane you can see there is a rectangle, on a horizontal plane once again you can see a rectangle, on a profile plane once again you can see that there is a rectangle, but the overall view is still three-dimensional, isn't it?
Yes, sir.
Yes, sir. Now I cannot take a print of this and say that this is a 2D drawing. Am I right?
Yes, sir.
Yes, sir.
Then how can I convert this into a 2D drawing? I have drawn it to, I have done the orthographic projection, but the conversion has not happened. Now, let's see if somebody can give me a hint. Any idea?
By turning the profile planes and the
By projecting
horizontal
it.
planes to the same plane or vertical plane.
Okay. Anyone else? Someone else was also saying something.
Means dividing in 4 coordinates and projecting in 4 coordinates.
Projecting in 4 coordinates. Okay. Anyone else want to add something? No, you all know. I know that you all know that, but okay. So let's see. Now what I'm going to do here
Sir,
is,
sir, by rotating vertical plane and profile plane by 90 degree.
okay, the approach is correct, but the step is wrong. We do not rotate the vertical plane. The vertical plane always remains locked. We will discuss about that. Let's go ahead. Let's go our mind forward. Still, it is not a two-dimensional drawing. Okay. So let's see. Vertical plane will always remain fixed. That thing I want you all to keep in your mind. It's like an axiom. It's always there. Vertical plane, you do not rotate the vertical plane. It's remain fixed and it is in front of the observer. Okay. Horizontal plane is a rotatable plane. I want you to note down and remember also that horizontal plane can rotate. Okay. Let's go ahead. Profile plane. It is also a rotatable plane. You can rotate the profile plane. So this is one characteristic about all these three planes. So I want you to remember very vividly, vertical plane always remain fixed. Horizontal plane can be rotated. Profile plane also can rotate. Now the question comes, if you rotate the horizontal plane, what could be the sense of rotation? Will it be clockwise or will it be counterclockwise? Now I have given you one answer that vertical plane remain fixed. Horizontal and profile plane can rotate. Now, can you recall?
Counter clockwise.
Clockwise?
Sir, counterclockwise.
Okay, I want you to keep your answers with you. Let's see. Now we all know this, that these were the three views. We have drawn the front view, also called as front elevation. We have drawn the top view on the horizontal plane, and then we have drawn the side or profile view on the profile plane. And, there are different nomenclature. Some people call it as front plane for the vertical planes. For horizontal plane, they call it as top plane because they draw top view on it. Then they call profile plane as auxiliary vertical plane. Okay. So these are the three views. Now we will come to this. We will come to this. Let's see rotation. So this was the question, that though we have drawn the projections, but it was still not a two-dimensional drawing. So how do we do about that? Now let's see. What we do is we open the planes. See here, front view remains there, or I can say vertical plane remain there, and we move the top view and profile view like that. is how we are going to readjust the planes so that when we draw these views, we will have a clear picture of what we are drawing, where we are drawing, and what view it is. Okay. This is what we should do if we are going to draw the orthographic projection of a matchbox, which was kept like that. Then this is how the view will look like. You see, you have front view of the matchbox in the vertical plane, top view in the horizontal plane, which has been rotated 90° in clockwise direction. Then you have profile plane, which was also being opened up in clockwise direction, and you have a right side view of the matchbox. We were looking from the right side, remember? Or should I go back to the slide? I guess you all can remember. That was just few minutes before. So we were looking from the right side, but where do we got the view?
On the left side.
On the left side, on the left profile plane. Why? We will come to that. All the questions will be answered, don't worry. So this is how it happens. If you're still unable to follow that, then I can give a quick revision of these 4-quadrant system. I believe you all are familiar with this. Even in the trigonometry also it has been used. So first quadrant, second, third, fourth. We talk about location with respect to vertical plane and horizontal plane. So these are the 4 quadrants. First quadrant, above HP, in front of VP. I will go quickly because I guess you have studied this in engineering drawing. Second quadrant, above HP, behind VP. Third quadrant, below HP, behind VP. And fourth quadrant, below HP, in front of VP. Now see, this is what are the things which we are going to see. Now see, now I'm going to convert this into a 2-dimensional thing. See, now when I do that, see what happened. The intercept between the vertical plane and horizontal plane will become my axis line, XY. Is it clear?
Yes, sir.
Yes.
Yeah, the intercept between, once again, I'm repeating, the intercept between the vertical plane and the horizontal plane becomes my reference axis. So that's why XY axis, which I denote by XY axis. Okay. Now you see, now let's say if your object is in first quadrant, this is what is first quadrant. So if you want from first quadrant, convert, if the object is in first quadrant and you want to convert it into a 2D drawing, then you are going to keep the vertical plane fixed and you are going to move the horizontal plane. Now you see I am moving the horizontal plane. You can see here. This become a 2-dimensional drawing, isn't it?
Yes, sir.
Yes, sir.
So I
Yes,
guess
sir.
question has been answered. How we move, which direction it is? Clockwise?
Clockwise.
Yeah.
Clockwise.
So in the first quadrant, if I'm going to draw the 2-dimensional view directly, then I'm going to draw a straight line. That will be my axis line XY. Where will be the plane? Where will be the vertical plane? The vertical plane will be above the XY line. Where will be the horizontal plane? The horizontal plane will be below XY line. Now I will ask you an interesting question. If I'm going to draw the front view of a 3-dimensional solid, then where will be the front view? Above the XY line or below the XY line?
Above.
Above the
Above the
Above
XY
the
line.
Above the XY line.
Good, good.
above.
Yes. If you are going to draw the top view, where the top view will be?
Below. Below X.
X line.
Below the XY
Below
line.
the XY line.
Yes. These are the standards. Nobody is going to tell you that this is the front view, this is the top view. If you know that this is the way the projection has been drawn, then you can easily read it out or you can easily infer from the drawing. Now let's say if something is there in the second quadrant. Now what we are going to do? If we want to convert this into a two-dimensional drawing, same principle. Fix the vertical plane, move the horizontal plane in the clockwise direction. If you do that, see here what is going to happen. So this is what going to happen. In a second quadrant, you have vertical plane and horizontal plane both above the XY line. Is it clear?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
And since I have moved
Yes,
the
sir.
horizontal plane, the horizontal plane is under the parenthesis. Vertical plane has did not move, so it was his space. Horizontal plane has come up, so it is under the parenthesis. Okay. Let's down. Let's say if something there is in third quadrant. Now I'll quickly go through. I think you all have understood the concept. Now once again, we will keep the vertical plane intact and we will move the horizontal plane in clockwise direction. Now you see what happened. It is kind of a replica mirror image of first quadrant. Am I right? Now you see here,
Yes.
the horizontal plane has gone up and the vertical plane has come down. Vertical plane has not come down. It was already there, but the horizontal plane has gone up. Now, if you are going to do a projection of an object which was there in the third quadrant, what will happen to the top view?
Above XY.
Above XY line.
Above XY line.
Yes. And the vertical front view will come below the XY line. Last one, fourth quadrant, both vertical plane and horizontal plane will become below the XY line. Okay. Now there is a very subtle concept which we all understand very clearly before we go to do the orthographic projection is first angle projection and third angle projection. What is first angle projection and what is third angle projection? Now you see, I'll give you an example. Okay. Let's see. Let's imagine that matchbox thing itself. You have a matchbox and you are focusing a torchlight on this matchbox, which is kept in a dark room. So you are going to get the image of the matchbox on the wall behind the matchbox. Am I right? There is a matchbox kept on a table in a dark room. You are holding the torch. You are lighting the torch on the matchbox and you are going to observe the shadow of the matchbox on the wall behind the matchbox. Am I right?
Yes, sir.
Yes, sir.
This I am calling it as first angle projection. This I am calling it as first angle projection. Okay. Now let me ask you a very funny question. Uh, have you ever watched a play or have you gone to theaters and watched movies, right? They have a screen there. Am I right?
Yes, sir.
Okay.
Yes,
Have you
sir.
ever noticed that sometimes the maintenance guy walk behind the screen and you see a shadow of that guy on the screen?
Yes, sir.
Is that phenomena common to all of you?
Yes, sir.
Or if you have a very thin curtain and if somebody is standing behind the curtain, then you can see a shadow appearing of the shadow of that person on that curtain. Am I right?
Yes, yes.
I'm calling this as third angle projection. I'm calling this as third angle. Now I want you to tell me at least one or two difference between them. I've given you the example. Think about it and tell me that what is the difference between first angle projection and third angle projection.
Position of top view and front view are opposite in both.
Okay. Anyone else?
observer is opposite to the source light.
Abhijit, you were there, but you did not convey it right. Yeah, I understand that you understood the concept. Anyone else want to try quickly? We'll not waste much time here. What's the difference? Okay, think about the position of the observer object.
Observer is lying in the front first quadrant, and for that another it was lying in the third quadrant.
Okay, Ayush. Okay, let me simplify this for you all. Can I say that in the first angle projection, the object is between the observer and the screen? Where was the matchbox? The matchbox was between you and the wall. Am I right?
Yes, sir.
Yes, sir.
Yes. Whereas in the case of the theater, where was the object?
Behind.
Behind the screen. Am I right? Or behind the curtains. So did
Yes, sir.
did there is a change in the position of the object with reference to the plane on which you are projecting it? Yes.
Yes, sir.
So from there itself, this concept has been evolved. First angle projection and third angle projection. Now you can see this picture and you can find meanings to it. If you are looking the thing what is kept in the first quadrant, you can see that you are drawing the projection on the screen which is located behind the, consider you are watching from the right side. Okay, consider you are watching from the right side. Now you see in the first quadrant your object is between the observer and the screen. If the object is kept in the third quadrant, you are still watching from the right side. Now can you see the difference? Now the projection plane is before the object. Am I right?
Yes, sir.
Same thing here. If you are looking from the top, you are drawing the top view on the plane which is after the object. Whereas if you see in the third quadrant, you are drawing the bottom view, before the object itself. Imagine you are looking from the top. So in case of the first quadrant object, you are drawing the image, you are drawing the projection after the object. Whereas looking from the top still, when the object is placed in the third quadrant, you are drawing the bottom view before the object itself. This is what is the difference between the first angle and the third angle projection. This is the symbol we generally use for the first angle projection. And this is the symbol we use for the third angle projection. How to remember this? In first angle projection symbol, you see the front view comes first and then comes the top view. Whereas in third angle projection, you see the top view has come, the bottom view has come first and then the front view. So you need to remember this, because sometimes when you are going to read a drawing of a machine element, then if this symbol is there in that drawing somewhere in the bottom or at the top, then you must understand that it is first angle projection or it is a third angle projection. Now let me simplify this for you. First angle projection means the object is kept in the first quadrant. Okay. Third angle projection means the object is kept in the third quadrant. This can be a very simple answer also, but that's not the exact answer. Okay, so like that you can remember. So first angle projection, where is the object? It is there in the first quadrant. Third angle projection, where is the object? It is there in the third quadrant. Okay. So a quick comparison before I conclude. See here. Quickly go through this. I have spoken enough. about the first and the third. Now in our course, we are basically going to do first angle projection. So for that first angle projection, I want you all to remember that the front view will be above the XY line. The top view will be below the XY line. The right side view will come on the left profile plane and the left side view will come on right profile plane. If you remember this much, you will commence few less mistakes. Okay, any questions? I believe this is the last slide for the theoretical discussion. Any questions? Before I go to the software part? Any questions? Any questions will be welcome. Don't hesitate to ask. But it must be related to what we have discussed right now.
Sir, in third angle projection, how you said it as
Yeah.
bottom view?
Okay. See here. Don't you think I said it the bottom view, but actually it is the top view itself. Sorry, means I chose the wrong word, but it's the top view itself. Because we are looking from the top. Okay.
Okay, sir.
Any other questions? I choose the wrong word there. I should have not said. Yeah.
So what about the profile planes, where they will lie, left or right?
I guess we have discussed that in this part of the slide where I showed you that which profile plane is this? Can you tell?
On the left side, sir.
This is left profile plane. Okay. So where it will be? You see the left profile plane. It is there in the left side of the front view.
Left side.
Which view you are going to draw on it? If it is a first angle projection?
Right side.
Right side view. Yes, always remember. So if you are going to draw the right side view of the object, then you are going to draw it left side of the front view. Is this clear? Tell me.
Sir, where
Yeah.
will the back view will come?
You do not need the back view. From these three view, it will be quite clear to you about
Sir,
the
if it is
profile.
unsymmetrical,
That's the question. In that case, you need to draw. So the back view will come above the front view.
sir, there it will come the bottom view, no?
Yes, that will be the bottom view of this.
But sir, a
Sorry,
back view,
back
sir.
view. Yes, it will come. This is the front view, top view,
Right
left
side of
side.
front view.
Yeah, it will come. That depends how the object is been aligned. Let's see. Let me tell you here. See, now if you are looking from here, then the back view will be the same rectangle what is there on the vertical plane, but with no matchbox written on it, right?
Yes.
Am I right? Yes. So that depends how the object is aligned. Based on that only you can decide where the back view will come. Any other questions? So shall I conclude this discussion part and go to the software? Tell me. Shall we go to do practice one orthographic projection?
Yes, sir.
Yes, sir.
Do we have students who are doing simultaneously with us, or you all are only going to watch how I'm going to do the software? I guess it will be better if you just see and note down few of the commands and things what I'm going to do, and later on you can practice in the software, because I don't think if we go parallelly it will take a lot of time. Then I have to ask you every time that did you complete it till here? If not, then many things will come that will take so much time. So let me do it in front of you, or you notice it, note down few important things, ask me the questions if you have, and then later on you can practice the same. Okay. Okay, so with that, let's jump into the Autodesk. Okay, now let me share.
Rahul, before that, I can clear some of the student I think is having some doubts regarding back view, so I can clear their doubts. I will just share one of my.
Should I show them, sir, all the views?
Yeah, they can. Here you can see. Here you can see there are designation of the view. These are A, B, C, D, E, F. You can see here. So basically here view in the direction of A, you can see this. So this is basically view from the front, right? And if you're we are seeing the view in the direction of B, that is view from the above. And here the third one, that is C, view in the direction C, that is views from the left. Okay, and then this D1, that is view in the direction D, that is basically view from the right. And if we are seeing this view in the direction E, that is view from the below. And then this F direction, that is view from the back or rear. So if you have to place that, you can place this side. Okay, that depending upon the angle of projection. But you can see this rear view is always the same position in both the angle of projection. Okay. I think
Yes, sir.
this is clear. Okay, Rahul, you
Yes,
can
sir, it's
continue.
clear.
You can continue.
Yes, sir.
I have to stop presenting now. Okay, yeah.
Okay.
Sir,
Yeah.
Yes.
sir, to describe a single part, do we ever need more than 3 views? However unsymmetrical it is.
Depending upon the means complex structure. Suppose you have a complex component. In some of the cases you need, but most generally will not need all the direct means views. Certain type of component or machine component is having difficulty in understanding, then only you have to show all those views. Okay.
Okay.
Okay, then we will start. We are going to practice one orthographic projection of a simple isometric solid. Now, this is the drawing window, what we have. And now let's start with the initial settings. Now, the first setting we need to do is we need to define the units in which we are going to work. So units. Now, for our mechanical drawing, we keep it in the decimal. With the precision, you can take it two digit after the point or up to 3 digit. Most of the drawings what we are going to practice here does not go into that region. Then here you need to scale, you need to select millimeters, because all the dimensions which we are going to practice here will be in millimeters. Now precision, millimeters, done. Okay, so that sets the unit first. Now, following up the units, the next thing you need to do is you need to set the limit. Now, limit is basically a way of describing the drawing area which you are going to use. Because sometimes you may draw the diagram without setting the limits, and when you take the print, nothing comes out. Or when you open the file next time, you do not see the drawing at all because you have not defined the drawing area. So very first, the second thing we need to do after the unit is to define the area. Okay. So you can select 0, comma 0 as your starting point, and you can specify that was also the lower left corner of your page. You can consider it's a A4 page. What is the dimension of A4 page? It's 297 cross 210. So let me say that that's 297 cross 210. So I have set a A4 page size of drawing area for my orthographic projection. Now, next thing, though you have set the limits, but still the things do not work according to you unless until you go for a zoom command and then you select all. Now, when you do that, now you are going to have real time uh, exposure to your drawing area and what you are going to draw here. So you have done the initial settings. Now other things, as we are going to draw the diagram together, means as I'm going to explain you the projections, we will figure out many other commands on the way. Now you can right away start drawing here, or you can just draw a reference rectangle, and in that reference rectangle you can draw the views. So it's up to you, it's not mandatory. But I generally prefer this to draw a reference rectangle so that I can draw my drawings in this reference. Okay, let's see. I have set the reference rectangle somewhat smaller than the space what I have given. Let's say this much. Okay. Now, what whose isometric view I'm going to draw? Now, let me show you that first. Okay. So we are going to draw the the orthographic projection of this isometric object. So you can see that it's a assembly object. Now, if you look very clearly, if I point my object cursor here, you see that there is an arrow here. Can you see? Next to the dimension line, which written 35 and 45 at the bottom, there is an arrow which is indicating towards the object, right?
Yes.
That arrow indicates that this is your front view. Okay, because if there is no arrow, then how can we figure out that which side I should draw as a front view? So to simplify that, you will always find in the questions or in the drawings also that there will be one single arrow, and that the arrow will indicate that this is the front side of the object. Okay, so this is the object. I have chosen a simple object today, whose orthographic projection we are going to draw. Okay. Now let's go ahead. Let's draw. I think I cannot switch between these things. So let me bring this drawing in the AutoCAD. Just a second. Okay. So now you all can see the drawing in the drawing window itself, right? Now you can zoom and find out what are the dimensions. You can come back and draw. So we are good to go. Can you tell me what is the first thing we need to draw?
Coordinate axis.
Very good. The first thing we need to draw is XY axis. So let me draw an XY axis. Now you see, I am having difficulty in making my line straight here, isn't it? You see, I'm struggling here. Do we have do we have some way of making it straight without making much effort? Yes, we have. See here where I'm getting my cursor down. I'm going to this toggle key, which is written as ortho mode. If I switch on this ortho mode, now you see, I do not have any struggle to draw a straight line. You see, I just click and here goes my straight line. So what do we learn here? That if this ortho toggle key is on, then you can draw perpendicular lines, horizontal lines and vertical lines. Clear?
Yes, sir.
Yes, sir.
Okay. What next I need to draw? The next I need to draw is this is XY. You can name it X. Sorry, that part we will do later. Yeah, that we can do later. Let's draw first. Then go to a line command. Now you see, I want to see where is the midpoint of this line. Now, if I place the cursor nearby, I'm not. I have to struggle a little bit. Now, in order to stop that struggle, there is something called as object snap. If your object snap is if your object snap is on, then you can easily find out where is the starting point of a line, where is the midpoint of a given line. That symbol is not coming right now. Let's not waste time. Let's draw it like this. So if that thing is on, that will clearly indicate you the midpoint, the end points, the center of a circle, the tangent to a circle. That will help you draw things which are related to coordinate geometry. Okay. Now I'm going to draw the front view of this drawing.
So there's the option side of the snap over here. We can switch the midpoint.
Yes, yes. Yeah. Yeah, Rupesh, we can. There are many ways, Rupesh, we can do that. Okay. Now let's see. Now the next question comes to our mind is, where should we start drawing it? Now, front view we need to draw above the XY line. Top view will come below the XY line. Now in this case, which is the side view we are going to look?
Left side view.
Yes, and where this left side view we are going to draw? The left side view will be drawn on the
Right plane.
right profile
Right
plane.
plane.
Yes. And right profile plane will be on the right side of the front view, correct? So if that is the case, then here, this is the place where we are going to draw the front view. Am I right? So that so that here the second side view will come and below the top view will come. Now I'm just giving you an idea. The more you practice, the more idea you will, the clear picture you can see, and you can decide within a fraction of a second that where you are going to draw the top view. Now, if the same image would have been twisted a little bit other way around, and suppose you are going to look from the right side of the image, then in that case you were supposed to draw the front view here, so that you can draw the right side view in the left profile plane. Is this clear?
Yes, sir.
Okay.
Yes, sir.
So now let's. What I am saying here is, right now, seeing at the object, we are going to see the left side view of the object. Okay. When we see the left side view of the object, the projection is going to be on the right profile plane, which will be on the right side of the front view. So if you somehow draw the front view here where the cursor is there, then you cannot draw something right of that. Okay. So you have to draw the front view here so that you can draw the left side view in the right profile plane. So you have to decide before drawing the front view, you have to decide that whether you are going to draw the left side view or the right side view. And how we are going to decide that based on the alignment of the object or the problem given to you. Clear? Is this
Yes,
clear?
sir.
Okay. So now let's go ahead and let's draw. Can you tell me? I am not expecting the correct answer or the exact answer. What could be the front view of this three-dimensional object? Let me zoom for you.
Rectangle.
Rectangle.
Yeah. The front view will be a rectangle. What dimensions? I can see this bottom dimension. It's 45, 35 plus 10, 45. So 90 mm.
to 70.
90 into
To
70.
70.
Okay, so we can go with the 19 into 70 drawing. Correct? So let me draw the drawing here. So take a line. Now slightly above the XY axis, you don't want to make things complicated for an observer. So you take a height slightly above the XY plane, specify the first point, and then the length you wanted is 90. So this is your 90 mm width. Now you want a height of 70 mm. Correct? So let's go with 70. Once again, you are going to close it 90 and you can click here or you can enter 70. Now this is all you can see. Tell
Yes,
me.
sir.
No.
With holes.
Yeah, yeah, definitely there is a center hole. What about that? You see, I'm zooming here. What about this step? There is a
We are
step
going
of
to
10
see
mm. Can you see that a step
10
2?
mm.
Yes, you can see a step 2 of 10 at a distance of 10 mm from this bottom one, right? How do you draw that? There are two ways of drawing that. You can start from this point, go 10 mm above, then you draw a horizontal line of width 90 mm, right? What I'm going to do here is, see, I'm not going to click anything. I'm just going to go to this specified point, just move the cursor up and I'm going to enter 10. Now it will automatically take 10 mm offset, or you can go for offset command also. There are many ways. See here, I have drawn a line at a distance of 10 mm from the bottom. You can go for the offset command also, which sir has discussed in the last class. Clear? Now let's check the dimensions. Do you remember how do we check linear dimension? Select the line. How do we check? Those were the things we have already discussed with you in the last week.
Connecting both the lines.
Select the starting and the second point of the line and just drag. You can see it is small. We will change that, but it's 90, right? Now let's check this, whether we have drawn this correctly. So this and this and this. So yes, that's 10 mm. Let's check the other dimensions also. This and this and this 70 mm. So far so good. Okay, I don't suggest you to draw the dimension lines during the drawing. That is the last part of the sketching. But just for the first case, first try, since we are doing it first, we need to make sure that we are drawing it correct. Otherwise, it will act as a hindrance for your drawing. You may not able to figure out or differentiate between your drawing and the dimensions. What next you can see? Tell me. What next you can see in the front view? Can you see these slant heights at the corner? These things, this is slanted here. But when you are looking from the front, from a very far thing, can you see this rectangle?
Yes, sir. Yes,
Yeah.
sir.
What is the dimension of that rectangle? See here.
60 from the front.
You cannot see 60, dear.
10 below.
Yeah, the thickness is 10. And what is the height of this? Can you see the height?
60.
50.
Hmm,
50.
somebody said
50.
so I have multiple answers, 60, 70, 50. What's the right one? See here. There is a gap of 10 mm here, right? So definitely this 10 is gone. And there is a step of this 10, right? So 20 gone. So you are going to see this with a height of 50 mm. Am I right?
Yes,
Yes.
sir.
Yes,
Yeah.
sir.
So how we are going to draw this? How we are going to draw this? Can anybody tell? There are many ways. I can draw a rectangle and I can move it inside. Or I can do the same thing. I can select the line command. Don't click anything. Just go there, trace the point down, enter 10. And from there, you start drawing. What is the thickness of that edge? The thickness of that edge is also 10. So 10. And where does that edge ends? What is the height? You can enter the height 50, let's say. Same thing the other side also. Go to the line command. Go to the starting point of this. Just bring the cursor down. Don't click anything. Enter 10. That will specify from where you want to start. Then 10 mm is the thickness and 50 is the length. So done. What else can you see in the front view? If you want to check the dimensions, you can check.
Rectangular hole.
What else can you see? Yes, you can see a rectangular hole. Can you tell me the position of that rectangular hole? Where do I begin? How do I identify where I should start that rectangular? I can see that there is a rectangular hole of length 35 mm. Sorry, width 35 mm and length 15 mm.
30 mm above. The 30 mm above.
30 mm above. 30 mm
20
above.
mm.
25.
See, I have mixed answer again.
Top is 30.
From top it is 30.
So bottom 25.
From bottom 25. Okay. Well, I guess you don't see this one. This you cannot see in the front view. I'm talking about this one. That is a square of edge 15 mm. I'm talking about this rectangle. Width 35 and height 15 mm. Now you can see that.
22.5 from the bottom.
Okay.
Above the.
Can I trace this point? Tell me. Can I trace this point?
Yes, you can trace
I
above
can trace this
30.
point. That is 45 mm from and that is how high, how much height is that? 10
30.
plus 20, 30.
30 mm.
So okay, let's trace that first. I'm doing like a beginner here. So we all are learning here. So let's trace that point. So you need to draw, you need to find the midpoint here. Okay, if nothing works here, then what you are going to do is, let's start from here, draw 45, then go 30. Okay, so now you have reached the center point of that rectangle, right? Am I right? Tell me.
Yes, sir.
Now still there are many
Yes.
ways of drawing it. Now still there are many ways of drawing it. One simple way could be that you go from here, you go down of how much? 7.5.
7.5.
Yes, and then you draw 17.5 this side, then 15, and then let's just see. I guess it's you. I don't need to explain it. You will follow it up.
So we can draw central rectangular.
Yes, you can do that. So from 7.5 down, I'm drawing 17.5 this side, then I'm going up 15, then I'm coming here 35, then I'm going down 15, and then I'm going this side 17.5, and I'm done with my rectangle. There are other way of drawing the rectangle. You can trace this point, and then you can take the rectangular command. I'm just telling you, you can take the rectangle command. You can specify the first quadrant. Let's say that this was the quadrant. If you could have specified this quadrant, then you could have simply drawn that rectangle by giving these dimensions here. So there are many ways of doing that. This is the simplest way. Okay, now I don't need this line. Do I need this line? Yes, I am
No,
going
sir.
to need this line in order to indicate that there is a hole. It's a hole, right? It's a rectangular hole. So I'm going to need that line. Keep it there like that. Or even you can elongate it a little bit. Okay. But you definitely need to trim slight part of it. Okay, that's fine. And you just draw it a little more here. Yeah. Okay. Then anything else you are going to see? Tell me. Are you going to see anything else? Do you know from the view that there is, from the view that there is a square hole also in this step, this 10 mm step? Do we have a square hole?
Yes, sir.
Do we have a square hole? Yes, we do have. But that is hidden to us. So we need to draw that hidden one. We need to draw that hidden one. So how we are going to draw that hidden one? We are going to draw it with the hidden lines, but for the time being, I'm going to draw with a normal line. Then we can make it at hidden lines. Now, where is that exactly? Where is that? Tell me. What is the dimension of that square? 15 mm, right? So the center of that square, or I can say if I trace the starting point of that square from the left corner, then it will be 45 minus 7.5. How much it will be? Tell me.
37.5.
Okay, so taking this as my tracing, I'm going to into 37.5 into, I got the point where that hole is there. Now I'm going to give 10 mm. Okay. Then once again, I'm going to trace from this point forward. The width of that square is 50. And then once again down 10. This is where the square is, but it's hidden. Now, how do I indicate? Let's indicate those things first. So these are hidden lines. I cannot see that there is a square hole there. What do I do it? I just select these lines, this and this lines, and I go to here, layers. Sir has discussed in the previous class that layers where you can define different types of lines. Do I need to explain you again? Now you see, I have made those as hidden lines. Now if I zoom it there, you can see that they are not continuous lines. They are like a chain line that indicates that it is hidden. Okay. Can you follow?
Yes, sir.
Yeah, so these are hidden lines. How you define a line? You can go to layers, and here you can click on this and you can define a line. You can define any type of line which you are going to use in your projection. You can define center line, you can define hidden object line, projection line 2. You can select projection 2, click on that. Then you see it will ask you to define the characteristics of that projection lines. So that can be, it can be, you can choose any color, let's say red in color. Okay, then you need to define what type of line it is. Will it be a continuous line? No, I don't want a continuous line. I want a continuous line to be a projection line, but its thickness has to be same, a little less. So what you are going to do is you are going to change the line width. Line width in AutoCAD talks about the thickness of the line. And there are standards where you need to specify a given standard thickness for all different kinds of lines. So here you can change it to 0.05 mm. OK. Now if I choose, so you have defined it. Now let's see what happens. If I choose a line here and if I go to the layer and if I select it to be a projection line 2, now you see what happens. What happened? It became a projection line, red in color. Now, if you are not able